Hello everyone, we are Team Tidex and our problem statement for SIH 2025 is coastal erosion detection and prediction using satellite imagery and machine learning. Now, why did we choose this? India has a vast coastline of over 7,500 kilometers, stretching across 9 states and 2 union territories. Along this long stretch, there are many places where people suffer from extreme erosion on one side and accretion on the other. These changes in the shoreline directly impact coastal communities, infrastructure, and local economies. For the people living near the coast, the challenges are very severe. Homes, farmlands, and livelihoods are constantly at risk. Fishing communities lose their income, tourist industries suffer, and in extreme cases, entire villages are forced to migrate inland as their land disappears. For governments and authorities, the problem is equally tough. Monitoring such a huge coastline is not very easy. Traditional shoreline surveys are slow, expensive, and cover only limited areas. There is also no reliable tool to predict future shoreline positions. This lack of accurate data makes disaster preparedness inefficient, and when cyclones or storms strike, the response often comes too late, leading to higher losses. That is why this problem statement is so critical. If we can accurately detect and predict erosion using satellite data and machine learning, we can help coastal communities stay safe, reduce economic damage, and enable governments to plan better for the future. Now that we understand how serious coastal erosion is, let's dive into how our solution works, step by step. Imagine you are looking at a stretch of India's coastline, over 7,500 kilometers long with villages, ports, and beaches all along it. Monitoring this manually is nearly impossible, right? That's why we built an interactive map where users can simply select their area of interest, any segment of the coast, and focus the analysis precisely there. This makes the process fast, accurate, and user-friendly. Once an area is selected, our system automatically fetches satellite images from reliable sources like Sentinel and Landsat. But raw images aren't perfect. They often have clouds, shadows, and noise that could mislead the analysis. So we clean and pre-process the images using advanced filters and cloud removal techniques to get a clear view of the actual shorelines. Next comes the exciting part, shoreline extraction. The system identifies the exact boundary between land and sea, then generates a baseline along the coast. From this baseline, we create transects, perpendicular lines stretching inland and seaward, which let us measure how much the shoreline has moved over time. By combining data from multiple images across months and years, we create a detailed time series record of coastal changes. Now, this data is then fed into our machine learning model. We use polynomial regression to predict how the shoreline will shift in the future, identifying zones of erosion and accretion. We validate these predictions using mean absolute error (MAE) and root mean square error (RMSE) to ensure accuracy. What's even more exciting is that our prototype already works on real-world locations. For example, on the Uppada coast near Kakinada, the system accurately predicts future shoreline points and highlights vulnerable areas. With this, decision makers don't have to guess, they get clear, actionable insights at their fingertips. Currently, around 80% of the prototype is functional. If you're an evaluator and have any questions, please feel free to leave them in the comments below. We'd be happy to answer them. Thank you.